Hey broskies, and welcome back to another video. So, can Bluestar actually be blue? Let's find out. Bluestar's parents are Moonflower and Stormtail. While Stormtail doesn't have any canon parents, Moonflower's parents are Daisytoe and Rooktail. So let's go ahead and start off with Daisytoe. Daisytoe is described as a gray and white. That means she would be XX for a black base coat, big S little s for some white spotting, little d since she's dilute, and her B locus could either be big B little b, or big B prime. As for Rooktail, he is described as black, so he would be XY for a base color of black, big S for no white, and either big D or big D for his dilution locus. His locus B, just like Daisytoe, could either be big B little b, or big B prime. Now, their daughter Moonflower is described as a silver gray she-cat with dark stripes. So we know she would be XX with a base color of black, big S for no white, and little d because she's gray, so she'd have to be dilute. This also confirms that Rooktail would have to be big D because if he were big D, Moonflower could not be dilute. Okay, so here's where we run into some problems. What exactly does silver gray mean here? Is she just gray? Is she pale gray? Is she blue? Unfortunately, this opens up a new locus for us to go over. Because if you've noticed in my previous videos, I never really go over tabby. Tabby is completely different than the genetics we've learned so far. With that being said, let's go ahead and just dive right in. So there are two major things that can affect whether a cat appears tabby: the agouti locus, otherwise known as locus A, and the tabby locus, or locus T. So we're going to start with the agouti locus, just because it makes the tabby locus easier to understand. The agouti gene controls whether an individual hair on a cat are either solid colored or banded. So if a cat does not show agouti, the hairs are solid, but if the agouti is expressed, the hairs will become banded with a lighter pigment of the color that the cat is. So for example, a dark brown cat might have a lighter brown or a yellowish band throughout the fur. The alleles for this locus are big A and little a, big A being dominant and showing agouti, and little a being recessive and not showing agouti or showing a solid color. But remember, agouti only affects the individual hairs. This is where the tabby pattern comes in. Tabby, or locus T, has three separate patterns. Well, it has a few more, but we're just going to focus on the three. There's tickled, mackerel, and blotched. Blotched is also known as classic or marbled, but we're going to call it blotched because of the alleles and how they're labeled. It'll be easier to understand. So a tickled tabby is actually the absence of the tabby pattern. So instead of there being obvious stripes in the cat's fur, the fur has more of a salt and pepper look because of that lack of pattern. So the alleles for tickled are TIA and TI+. TIA being dominant and TI+ being recessive. So cats with TIA, or TI+, will appear tickled, while cats with TI+, allows for non-tickled patterns to show through. This is where we introduce the next two patterns, which are mackerel and blotched. Their alleles are TM for mackerel and TB for blotched, TM being the more dominant of the two. So if a cat is TM or TM-TB, that will show a mackerel tabby, and if a cat is TB-TB, it would create a blotched tabby. Now, something a little bit interesting about the tickled gene is even if a cat is genetically mackerel, if the tickled gene is showing, it will cover any other pattern. So it will cover mackerel and it will cover blotched. This also means that the tickled gene is epistatic, which basically just means it masks everything underneath. So you may be asking, why do some tickled cats have tabby stripings showing through on parts of their body? It's believed that the tickled gene actually shows incomplete dominance, meaning that if a cat is TIA, TI+, whatever pattern is underneath, for example, blotched, will somewhat show through. Okay, so let's just get back to agouti and tabby together. Here's the easiest way to think about it and the way I kind of understood it. The tabby gene is kind of like a stencil. So the stencil is always there on every cat. So technically every cat is tabby, but the agouti gene decides whether the stencil is actually filled in and colored or not. So even a cat that appears solid color still genetically has tabby patterns underneath. You just can't really see them, although sometimes you can see them under certain lights. Okay, so back to Moonflower. She's described as a silver gray she-cat with dark stripes. That means that she would need at least one Agouti allele, either big A or big A little a, in order for the stripes to actually show through. As for her tabby pattern, I'm assuming they would mean either mackerel or blotched, since tickled doesn't really show a striping. So that means she would likely be TI plus to not show that tickled. And let's just say they wanted her to be mackerel. That means she'd either be TM or TMTB. But of course, there's always a problem. Both of Moonflower's parents are solid colored, meaning they would likely be little a since the non-Agouti gene is recessive and they're not showing it. And since both of her parents would be little a, Moonflower would also have to be little a, meaning she wouldn't physically be tabby at all, or showing it at least. But remember, she would still have the pattern underneath somewhere, whatever it would be. So realistically, Moonflower could genetically have almost any tabby pattern, it just wouldn't actually show. And because of that, I'll interpret her silver gray description as just gray, rather than a lighter Agouti modified gray, meaning her locus B could be either big B little b, or big B prime, just like her parents. Okay, so now let's just move on to Bluestar's father, Stormtail. Stormtail is described as a blue-gray, and there is an argument to be made that he could be a tickled tabby rather than a solid cat, since he is described as blue-gray and not blue or gray. But just for simplicity, I'm just going to treat him as a solid blue. So Stormtail would be XY for a base color of black, big S for no white, little d for dilute, and he could either be, just like all these other cats, big B, little b, or big B prime. So we've actually kind of set up Bluestar for the perfect scenario here, because both of her parents visibly show the dominant black allele, but since black is dominant, they could also be hiding either little b or B prime, so she could be any combination of locus B at this point. Now, of course, we do want her to be pale blue, just like the books say, so she would be XX for a base color of black, big S for no white, little d for dilute, and we'd either want her to be little b or little B prime. Because again, if she inherited that big B, she would just be a normal blue-gray instead of being that pale blue-gray that we want. All that being said, yes, Bluestar could be pale blue, just like in the books. Thank goodness. Okay, before we finish here though, let's talk about Snowfur. Could Snowfur actually be fully white? In short, the answer is no, she can't be white. But let's go over why. So there's actually a second locus for white coloring in cats, and it's called locus W. And I did find out in some of the comments that the reason why locus S is because the S stands for spotting. So locus W is actually epistatic, just like the tickled gene. This means that any cat that has a dominant white allele, or big W, would show white regardless of what the other color that they are. So they could be genetically black, they could be genetically orange, it doesn't matter, the white would cover those colors. So at least one of Snowfur's parents would need to be showing white in order for her to inherit that white, or big W. And since neither Moonflower nor Stormfur are white, Snowfur genetically can't be the dominant white from the locus W. However, the writers from the books did give us a saving grace in that Snowfur also has gray ears. So instead of her having a dominant white from the locus W, she could potentially have a mostly white from the locus S, or little s. Now, in order for her to be white and Bluestar to also not have any white, we could give both Moonflower and Stormtail big S, or having some white, so that way Bluestar could inherit the big S and have no white, while Snowfur could still inherit the little s and have a lot of white. Not all white, just a lot of white, and still have that little gray ears. In that case, Snowfur would likely be XX for a base color of black, little s for the extensive white spotting, little d for dilute, and probably big B, little b for the gray color on her ears, although you could argue little b or little b prime. So she could be what she looks like in the books. We would just have to edit their parents a little bit to have a little bit of white, but I'm okay with that since we could just hide it on their feet or something. Alright, and that's my very extensive video over Bluestar and Snowfur. So thank you all for watching. If you liked the video, leave a like. If not, that's totally fair. See ya!